Mahamano Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Alternating current power supplies. In this module, we are going to study about the introduction, construction, working, and uses. Alternating and direct current. Electricity is delivered in one of the two forms, alternating current or direct current. Direct current is unidirectional. This means that the current only flows in one direction. A battery powering a flashlight is a good example of DC. The current and voltage from a DC power source are both unidirectional and constant. Alternating current periodically reverses direction. The most common AC output is a sine wave. The electricity that powers your home and business is AC. AC is much easier and safer to distribute than DC, as the voltage can be increased greatly through the transformer with a correspondingly large DCs in current. The lower current reduces the energy loss due to resistance in the wire when being transmitted great distances. An electrical generator can either be output of AC or DC depending on its design. The principle of electricity generation through electromagnetic induction is the same between the two, with a modification to the way and the current leaves the armature that determines whether the resulting electricity is AC or DC. Figure shows alternating current and direct current. The AC generator. The AC generator uses the rotation of aircraft's engine to spin multiple loops of conducting wire in a magnetic field. An alternating current is generated in the wire due to the electromagnetic induction. The workings of a generator are best described using a single loop of rotating wire as an example. This can be either extrapolated to multiple loops as in the case of functional generator. The armature is the moving portion of the generator and consists of loops of conducting wire arranged such that the AC current will always be conducted through the wires due to electromagnetic induction. The slip rings are located at the ends of the armature and the feed current induced in the armature into the broader electric circuit. Slip rings allow for the easy transmission of the current generated from rotating armature to the stationary circuit. These are two slip rings in an AC generator and one is attached to the each end of armature. These slip rings rotate with the armature and slip past a set of brushes, transferring the current from the armature into the circuit. This figure shows the AC electric generator. The brushes are stationary but kept in constant contact with the slip rings in order to conduct and transmit electricity generated by the armature. Referring to the image below, we can see how the arrangement of two slip rings and the brushes result in the AC current being fed into the circuit. The DC generator. An aircraft's electrical system runs off DC and not AC. This is primarily due to the fact that the system must be powered by a battery when the engine is not operational. Batteries are DC by design. It is relatively easy to modify the AC generator described above and output a DC signal. This is accomplished by replacing the two slip rings with a split ring commutator, whereas the two ends of armature are connected to a separate slip ring in the AC generator setup. The DC setup uses a single ring which is split such that each half of the ring is completely isolated from each other. Each end of the armature loop is connected to one side of the single ring. The commutator then rotates as before, contacting the sides of two brushes and passing the current into the circuit. The split ring ensures that each brush retains the same polarity throughout the operation of generator. The commutator provides a steady DC output that can be used to charge the battery or run any of the electronic system in the aircraft. This figure shows the slip ring for use in AC generator and the DC electric generator. An armature made up of a single loop of conducting wire would not make a very effective generator, as the magnetic flux lines are only crossed every once 180 degree as the conductor rotates. In reality, an armature is made up of many loops of wire such that the loops cross through the flux lines at much greater frequency than it would occur with only single loop. This helps to provide a smooth and even electrical output to the circuit. The AC alternator. The AC alternator is a type of electrical generator that has largely replaced all the DC generator described above in the use of light aircraft and automotive vehicles. The alternator serves the same purpose as a conventional generator, but it is smaller, lighter, and requires less maintenance than a generator is replaced. The alternator still works on the principle of electromagnetic induction, where a changing magnetic field induces a current on the coil winding, and the primary difference between alternator and conventional generator is that an alternator in the magnetic field is rotated by engine driven shaft rotor, while the coil windings remain stationary stator. A cutaway of typical alternator is shown in the next slide. The rotor is connected to the mechanical drive shaft and consists of a centrally located electromagnet which is energized when the alternator is operating to provide the necessary magnetic field. The rotor forms the rotating portion of the alternator which spins inside the stationary stator ring. The stator contains a set of coil windings wound around the ring into which the current is induced as the rotor spins. This image shows the cutaway of the AC alternator. An alternating current is output by the stator coil windings, which is transformed into a DC by a device called a rectifier. The rectifier uses a set of diodes which can be thought of an electrical equivalent of a one-way valve to straighten out the alternating current into a DC signal that can be used to charge the aircraft battery or run electrical system. An alternator can provide a more consistent delivery of electricity over a wider range of operating speeds when compared to the DC generator. This is due to an automatic voltage control device fitted into the alternator, which can regulate the current fed to the electromagnet, thereby increasing or decreasing the strength of magnetic field. In cases where the engine is RPM low, idle, or during taxi, the regulator increases the strength of magnetic field to compensate for the lower rotor speed. When the engine is running at high power setting, the regulator reduces the voltage going to the electromagnet, which reduces the strength of magnetic field. In this way, a constant alternator output can be maintained over the full operating range of the aircraft's engine. The electromagnetic rotor is powered through the field circuit which connects the rotor of the aircraft DC battery through the set of slip rings and bushes. The aircraft's battery is responsible for providing voltage necessary to operate the electromagnet. This can be a problem if the battery is flat before the engine is started or alternator will not operate on the flat battery. The brushes in the field circuit conduct only current required to energize the electromagnet. This is a fraction of the current that is output by an alternator, which dramatically reduces the wear on the brushes. In a conventional DC generator, the brushes must conduct full generator output, these higher currents increasing arcing and wear on the brushes. This figure shows the types of electrical motors and its classification.